Hello there, we are from Group 4 of Plant Risk and Reliability of 12 weeks class, and today we are going to present to you about RAM study for gas processing plant. And these are the group members of Group 4. So these are the contents of our slides. Now let's start with the introduction. I will define the word reliability, availability, and maintainability. Reliability means the probability of survival of the unit or system operates over a certain period, while availability means the percentage of uptime over the time period and is determined by reliability and maintainability. Whereas maintainability means how the system in use can be restored after failure and at the same time considering the preventive maintenance. So by taking the first letter of each word, RAM means the sustained capability of system throughout its useful life. Know that by using RAM analysis, we can estimate the production availability of the system by assessing failure modes, frequencies, and consequences, all the while paying attention to the effect on production. Moving on to the objectives of this project. This project has several objectives that need to be achieved, which are first, to establish an assumption used for the case study, then to evaluate the plant reliability for a period of 3 years based on data gathered from the plant, thirdly, to identify the bad actors that contributes to the availability figures, and finally, to propose action plans that need to be done if plant were to achieve 99% availability.
Moving on to the methodology for this project. For the first part, which is the repairable system, so basically this system gathers the number of failure over time. In this system, there are two types of variables, which are the number of failures over time and the time between successful failures. In order to complete this project, some assumptions were made, which are: first, the system is at the same state during after repair and before failure. And then the second assumption, which is most repairs involve small fraction of systems component and all other components remain at the same age. And then the third assumption is the rate of occurrence of failure is not constant. And then the last assumption is total number of observation time is 3 years after the cumulative time to repair. Okay, let's proceed with the data analysis and calculation part. In this part, we are supposed to conduct the data analysis through wearable software. But instead of using the app, we created an Excel template to accomplish our second objective, which to evaluate the average availability of the plant for a period of 3 years based on the failure and repair data gathered from the plant. The figure shows the Excel template that we have created. So, from this template, as we can see, the table on the left side is the data from our plant, and on the right side is the results that we have obtained from the data given. So these are the formulas that were used to calculate the eta and beta value. Then, from the eta and beta value, we can calculate the expected number of failures between period, the expected reliability between period, the MTBF between period, and the availability of an equipment using all of these formulas. That's all for the methodology part.
So this is the result for the overall natural gas processing plant.
In short, engineer can calculate and significantly predict how reliable and available the system is by taking reliability, availability, and maintainability analysis towards the system. Other than that, the bad actor, which is the component that contribute towards lowering the system availability, can also be identified. For our case study of over a period of 3 years, we obtained a reliability of 4.79405 to the power of 10 negative 5, and our availability of our system will be 0.945. With that being said, in order to achieve availability of 99% or 0.99 towards our plant availability, there are a few actions that we need to take into consideration, which is the first one will be the quality of maintenance practice, where we need to ensure an obsolete and consistent quality of maintenance practice that will be delivered in maintaining our system. By this, it will result in high availability as well as low down time or mean time to repair. The second one will be the quality of the component, where instead of contemplating about the price, we should go for a component that suits best for our machine. And this will also result in high mean time between failure as well as increasing the high availability towards our system. And the last one will be the availability of maintenance material, where we need to ensure all of the parts that in our plant is ready stocked. By doing this, we can low down the MTTR of the equipment, thus increasing our availability. Thus, it will be the end of our presentation. With that being said, thank you very much for listening towards our presentation.